All right. So now we'll be going on to logarithm equations. So we have examples to show how these expressions and equations can be manipulated. So let's do number one. We were asked to simplify log to base a of x squared plus 3 log to base a of x minus 2 log to base a of 4x. Now, in this case, we begin to apply our logarithm laws from the addition multiplication law where we add 2 log together, the division where we subtract them, and the power. Now, you recall that log a of x to the power y is equals to y log x to base a. So we can now write further, that's log base a of x squared, where this 3 now will become a power to x of log a x raised to the power 3, and this 2 also becomes a power to 4x. Okay, so log a 4x squared. Please note that it will not log a 4x squared. Okay, the two are captioned. Okay, so we have log to base a of x squared plus log to a of x cubed minus log to a of 4 squared is 16x squared. Now, since they all have the same base a, they can all be combined together. Okay, so start log a x squared and x cubed are multiplying together, so that will be x squared multiplied by x cubed, and since it is now subtracting for this, so that means it will be divided by 16x squared. Okay, so with this we have it to be log a of x raised to the power 3 over 16, and that will be our final answer. So we have number 2, and it says solve the following equation for x, and we are given that log to a of x minus log to a of x minus 1 is equals to log to a of x minus 2. Now, in this scenario, we can see that there is an equal sign here. That means we have equality sign. Okay, so in this case we are going to simplify the left hand side and equate it to the right hand side. Okay, so let's apply our laws of logarithm here. Remember that this will now become a power, so this will give us log a of x squared minus log a of x minus 1 is equals to log a of x minus 2. Okay, now since they are subtracting each other, so we have this log, and we can as well bring them to the other side, but for easy sake they are subtracting, so it will be division. Log x squared divided by x minus 1, okay, is equals to log a into x minus 2. Now we realize that the common variables here are log a, log to base a, so we can equate the numbers and say that x squared over x minus 1 is equals to x minus 2. Okay, so we cross multiply. In this case we have x squared is equal to x minus 1 into x minus 2, so our x squared will be equals to x squared minus 2x minus x plus 2, so x squared is equals to x squared minus 3x plus 2. So in this case we are left x squared is common on both ends, So 0 is equals to minus 3x plus 2. So my x will be equals to 2 over 3. Now, having solved that, we can have quite a lot of logarithmic equations. Okay, so we have number 3, sorry. Now it says for what values of x is log to base a of x minus 3 valid is it's quite common, especially when we have objective question. So we have log to base a of x minus 3 is valid, okay, is valid when the is greater than 0. Okay, now we remember that anything log of a number or log of a number is 0. I'm saying log of 1, okay, when it is logarithm is greater than, or like anything log of 1 is equals to 0. So the answer there, the value is valid when it is equals to or greater than 0. Okay, so that means our x will be greater than 3. So that's the answer. So a logarithm equation is valid when the number is greater than 0. Okay, please take note of that. So now we can also solve logarithm equation in sense of having let's go example 4. Given that log 2 log to base 2 of x squared minus 2x plus 5 is equals to 2. Now how do we solve this equation? Now if we will be called from our previous, okay, if we recall from our previous goal that we have if a is equals to b raised to power c, then c is equals to log a to base b. Okay, so all we have to do now is have to apply this principle into this question. Okay, and we'll apply this principle into this question, definitely we'll be realizing that this one becomes a power of this. So we have that x squared minus 2x plus 5 is equals to 2 raised to power 2, because we'll realize that this is our c, this is our b, and this is our a. Okay, so we will now make it in terms of this. So a, b, c. All right, a, b, c. So in the scenario, we will now solve these when we open up. So we have x squared minus 2x plus 5 is equals to 4. So x squared minus 2x plus 5 minus 4 is equals to 0. X squared minus 2x plus 1 is equals to 0. So in this scenario, we have it to be what? A quadratic equation. So when we solve this, whatever method you use, we have our final answer to be x is equals to 1 twice. Now, we can also have a question in relation to that also. That given log to base 4 of x squared plus 15 is equals to 3. Okay, just like we did before, if a is equals to b raised to power c, then c is equals to log b of a. So in this scenario, this is our b, this is our sorry, this is our a, yes, and this is our c. So our a is x squared plus 15. We are applying this now. Is equals to db. db is 4 and the c is 3. So x squared plus 15, okay, is equal 4 raised to power 3. That's 4 by 4. 16 by 4. That's 64. and if we make this the formula, so 64 minus 15. Okay, so my x squared is equals to what? 49. So in this case, if we take square root of both sides as with 49, remember there's plus or minus. So our x is equals to minus 7 or plus 7. Okay. So questions can come in handy and handy and handy. So let's try and take two more, and then we'll wrap up this video. So let's say we are given the problem to solve for y. Okay. So the question says solve for y, and that's number 6. Find y in terms of x, and we're given 5 log a y minus 2 log a into x plus 4 is equals to 2 log a y plus, okay, log a y, log a x, sorry. Now the first thing we have to look at is the first thing we check is, are they all of the same base? Yes, if they are all of the same base, good thing. If they are not of the same base, then we change our base. Remember how we used to change base, okay? So now this one shows that they are all of the same base. Okay, now I want to find y in terms of x. So the first thing to do now is to bring all the y together and take all the take the y to the left hand side. I was making y squared the formula. So quadratic times bringing y to the left hand side minus 2 log a, and bring all the x to the right hand side equals to 2 log a into x plus 4 plus log a of x. So now after doing this, then we move on and we apply our laws of logarithm. So remember that should I say x, okay, x log a y is equals to log a y raised to power x. Okay, so if we apply this law here, so we'll be having log to base a y raised to power 5 minus log to base a y raised to power 2 is equals to log to base a of x plus 4 all squared plus log to base a of x. Now, having done that, applying the law, then we move on to applying the laws of indices, where we have log a, or let's say log xy of a is equals to log to base a of x plus log to base a of y, and log a of x divided by y is equals to log to base a of x minus log to base a of y. So in this scenario, then we apply them to this law. So since we have subtraction here, right, so it will end up being division. So we have log a of y raised to power 5 divided by y squared, okay, will be equal to log a of since it is addition that is here, so it becomes multiplication in logarithm, x plus 4 all squared plus x, it becomes multiplication, sorry, multiplied by x. Now log a, now if you apply law of indices here, that's y raised to 5 minus 2 is equals to log a to base a of x into x plus 4 all squared. Okay, now log to base a of y raised to power 3 is equals to log to base a of x into x plus 4 squared. We can change these brackets to make it more reasonable. So now we realize that these two base, log to base a are similar, log to base a are similar. Then we can equate the numbers. X raised to the power 3 or y raised to the power 3 is equals to x into x plus 4 all squared. Now the question says we should make find y in terms of x, right? So definitely all we just have to do is the cube root of both sides, so y cube root of x into x plus 4 squared. Okay, since that is done, so we've established something as regarding that. So there are also tons of questions to do this. So we can also have, let's say, have a final question. Let's see, we got question 7. Let's say we are given log to base 10 of x squared minus 5x plus 50 is equals to 2. Yeah, so in this case also we apply our rule that if a is equals to b raised to power c, then c is equals to log a, right? Yes, then c is equals to log to base a of a. So definitely in this scenario, my 10 is b, okay, my 2 here is my c, and this one it's my a. So if I apply this here, so my a is x squared minus 5x plus 50, okay, and my b is 10 and my c is raised to power 2. So I have x squared minus 5x plus 50 is equals to 100. So x squared minus 5x plus 50 minus 100 is equal to 0. So my x squared minus 5x minus 50 is equals to 0. Now if we solve this however format you have, so we have that our x is equals to minus 5 or our x is equals to 10. So this will bring us to the end of indices and logarithm in general. So we're able to look at the rules of indices and we solve questions on indicial like equations that has indices in it, which are called indicial equations. And also we look at the laws of logarithm, look at the change of base formula from one base to another. We also consider base 10 and base e, and also solve questions related to logarithm equations. Okay, so with that, thank you very much guys, and I hope understanding has been established. Shalom.